Okay, here we go again. Let's see if I can get this. Let's see if I can do that. Down, out. I don't know what to do. Guess I'll just do it like this. We're all on? All right. So today we're going to do integration by substitution. This is used for when you don't know how to do the multiplication or division rule, because there is no multiplication or division rule. So here we go. So use substitution. So they start with example 1. By the way, I'm on page 432 in your book, so you could be following along. And I titled the examples the same numbers as they were. So we have integral of x squared plus 5 to the third times 2x dx. And none of that is, you can't do a multiplication because you can't multiply inside there because that's to the third power. And we don't have a power rule. So you can't do that. So you have to use the multiplication rule or the substitution rule, which means you pick a u. You're going to substitute u. So usually you pick whatever's inside the parentheses as u. So u equals x squared plus 5. So here's my steps right here. So you might want to write down the steps in your spare time. All right, step 2, derive u. Derive, not divide, derive. So the derivative of x squared is 2x dx. Note, whenever you get a du, you have to get a dx on the other side or whatever variable you're using. So when we're doing word problems later, it'll be a different variable. But right now we're going to use x. So whenever I derive an x, I get a dx beside it. So 2x dx. Step 3. What matches in the original becomes du. So I look and I saw 2x dx and I go, whoa, that's up here. So 2x dx now is going to be written as du. Well, x squared plus 5 is already u. So that's now u cubed. Can you integrate u cubed du? Yes. So you're going to integrate that. So step 4 is integrate that. And step 5, we'll get there in a minute. So we're going to integrate u cubed. Well, the integrated u cubed is u to the 4th over 4 plus k. Step 5, resub the u. Your answer can't have u's in it if you started with x's. Just saying, your answer can't have u's in it if you started with x's. So you have to resub u, x to the 2nd plus 5, quantity to the 4th, all over 4 plus k. That's your answer. Okay? So you keep doing that. Now I'm going to show you 6 of the 7 examples from the book. Okay, the next one, doesn't have much. So I still have to pick a u, so I'm going to pick 2x plus 1. Usually it's the most difficult part of the problem or the quantity. So 2x plus 1 is a quantity, and I derive it and I get 2 dx. And I go, wait a minute, I only see a dx the same. I don't see that 2. So you divide that 2 out and put it on the outside as a fraction, 1/2. Now the rest, that 2x plus 1 is on the denominator and it was u, so it's 1 over u du. Well, what's the integral of 1 over u? By golly, it's ln of u. So now you have 1/2 ln of u plus k. What's the last step? You resub back in u. You resub back in u, and you get 1/2 ln of 2x plus 1 plus k. Answer. Okay, so over here I said the 2 didn't match, divide it out. Put it on the outside of the integral. All right, so example 3. Having fun yet? Integral of x, square root of x squared plus 1 dx. Notice, usually my underlined black parts are what matched the derivative after I got that far. So the original problem is just in green. So I pick my u, x squared plus 1. Derive that. I get 2x dx. And again, I look for what matches. What matches in 2x dx was x dx. dx and an x, they don't have to be beside each other, but multiplication is commutative, so I can move them around. So those 2 things make du. What do I do with this 2? I divide it out. I stick it on the outside. What's the square root mean? U to the 1/2. Can you integrate u to the 1/2? Yes. So here we go. U to the half is now U to the 3 halves over 3 halves, but don't forget that we had a times 1/2 because that 1/2 is out there. I went slowly on this one. I'm not going to go this slow on the rest of them when I do these over 3 halves. So I have to flip and multiply that 3 halves. So U to the 3 halves over 3 multiplied by 2 times the 1/2. The 2's will go away, cancel. So I get 1/3 or over 3. And then I resub the U, x squared plus 1 to the 3 halves all over 3 plus k. That's your answer. Those are the first 3 examples. Ready for the next 3? It's not hard. It just takes more steps. All right, and we use all the derivative rules. So you have to make sure you're using all your derivative rules. Oh, let's see where my watch is. Let's see where my picture is. Why, by golly, there I am. All right, here we are. Example 4, the integral of x squared e to the x cubed dx. That e is to the power of x cubed. So the first thing you have to do is, what's your u? Well, you guys have to learn to pick those. You can't, they're not always going to be sitting in front of you. So you have to learn how to pick those. So u is the hardest part of the problem. Well, the hardest part of the problem is the exponent of x cubed. So I derive that, and I get 3x squared dx. I always underline. By the way, it doesn't matter if I wasn't using this whiteboard and I was teaching at school, I would always underline. If I'm doing it on my quizzes and tests and making an answer key, I always underline what's alike. What's alike is x squared dx. X squared dx becomes du. What's left? E to the u. Well, what? Oh, and where does this 3 go? Divide it out. It goes on the outside. So you have 1/3 integral of e to the u du. What's the integral of e to the u? Itself. 1/3 e to the u plus k. All you have to do, resub back your u, and then you're done. 1/3 e to the x cubed plus k. Answer. Good enough? All right, next problem. Well, this is kind of crazy. Integral, remember, you're writing what's in green as your problem. Integral dx over x ln of x. So everything is on the denominator. That doesn't make sense. So you have to pick a u. By the way, if you pick a bad u and it doesn't match anything in it, then you probably picked a bad u, pick the other thing. So here, if you accidentally picked x as your u, that wouldn't have worked because the derivative of x is 1, and that doesn't get rid of the ln. So we're going to pick u as ln of x, and we derive it, and we get 1 over x dx. Well, what's this? This is really 1 over x dx. So that's why I underlined it, because it is the exact same thing as that. So the exact same thing becomes a du on the numerator, but this ln of x, which we picked as u, is now on the denominator, so 1 over u du. Integrate that. Well, I just taught you an integration rule about 3 days ago. What's the integral of 1 over u? By golly, it's ln of u plus k. Now, this is a really strange answer because you have to put the u back in. The u was ln of x, so it's the ln of x plus k. That's your answer. It's okay. It's weird, but it's okay. Don't ask me where you use that. I don't know. All right. This one's another one. By the way, I jumped to example 7. I didn't think I'd have enough room to do both. I might have, but I didn't think so. So it's a good thing for you to practice example 6 on your own. But I'm going to do example 7 right now. So I have the integral of x square root of 4 plus x dx. So I think, well, what's my u? Well, u is always the inside part, so I chose it as the inside part. U equals 4 plus x. What's the derivative of that? 1 dx. Well, that just gets rid of that. That does not get rid of this x. So you can't have an x. So the next thing I do is I say, okay, let me put down what I do know. Pretend this isn't all here. I know that dx is now du. I know that this square root of 4x plus x is now u to the 1/2, but I don't know this part. So pretend like you don't see that. Okay. Then go over here. You can't have x with u's. So this was an x before. Well, you can't have that. So how can you change or solve for x? Well, you take your original u that you chose, 4 plus x. I'm writing it down here. Solve for x. So I subtract 4. I get u minus 4 equals x. That u minus 4 is what I put in that x spot. So u minus 4 times u to the 1/2 du. And I know the first thing you're going to say is that doesn't look any better, except for because the power is on the singleton, I can distribute it. If the power was on the quantity, I couldn't, and that's why it didn't work up here. But it's on the singleton, so I can distribute it. So what's u to the 1/2 times u? U to the 3/2. What's u to the 1/2 times 4? Negative 4u to the 1/2 du. So, and that just says distribute. Then you integrate that. Okay, now I'm going to integrate this a little bit faster. Ready? So you add 1 and you get 5/2, correct? Watch. U to the 5/2 over 5, flip it, 2 is now in the numerator. So technically 5/2 is on the denominator, like it was on example 3. But I flipped it automatically, and the 5 stays on the denominator, the 2 goes on the numerator. I'm going to do the same thing over here. This is 4 just comes down. That's u to the 1/2. If I add 1 to that, I get 3/2. U to the 3/2 over 3, flip it, 2. 2 becomes on the numerator again, plus k. Last step, substitute the u. 2 times 4 plus x to the 5/2 over 5 minus 8 times 4 plus x to the 3/2 over 3 plus k. Look at example 6 in the book. I didn't do it. I didn't have space. And your assignment is exactly what's on that syllabus. But if some of you haven't printed out the syllabus yet, it's this one. 6.2 is 436 and 37. 1, 7, 17, 25, 27, 29, 38, 39. Any questions? You guys will take questions tomorrow at Hangout. I'll be there at 8:30 and 1 o'clock tomorrow. Now, those of you who may not have been on a session today at Hangout, we're going to probably test on Wednesday of next week. We'll review Monday, Tuesday. I have not made up the test. I'm going to try to make up a version that's very similar to the questions that I gave you in their chapter review. Okay? That's all. Let's see if I can get this off and not have my finger in it.